morning. We'll continue to do numerical problems on mesh analysis. In the last lecture also, we have done simple problems on mesh analysis, and we will continue to do the same. We will determine the mesh currents, branch currents, and also voltages in a circuit using mesh analysis. So I'll be starting with a quick review of the 6 steps which we will be following, and then we will do a problem on mesh analysis. So a quick review of the steps. The first step is identifying the number of meshes and then assigning currents to each of these meshes, and then identifying the currents which are flowing through each of these elements. We will make a table of that, and then we will apply KVL to each of these meshes. After that, we will solve these equations to determine the mesh currents, and finally we will determine the required branch currents or branch voltage depending upon our requirements as mentioned in the question. So today's problem is this one. See, determine the current in each of the branch of the circuit shown in the figure using mesh analysis. So this is your circuit now. You are supposed to do mesh analysis, and you are supposed to determine the current in each of these elements, each of these branches. That will be your job for today. So before going for that, this one, let's identify. Let's follow the steps. Step number 1 is identifying the meshes in the given circuit. If you carefully see that this is one mesh, this is another one, and this is your third one, right? So step 1, your job is to identify the meshes. So there are 3 meshes in the circuit. Right. Step number 2, currents are to be assigned, right? So currents are assigned to each mesh. So I'll take the currents as I1, I2 and I3. Right. What are the currents which have been assigned? I1 and I2 and I3 to each of these meshes. Now step number 3 is about determining the branch currents. Right. So whenever we are trying to determine the branch currents, what we will do, it will be easier for us if we write a table. So this is the branch, and this is the current, and this will be the direction of the current, right? So when we follow these things, so how many branches are there? We will count the number of resistors in this one. 1, 2, 3, 4, 5, 6. We neglect the current sources or voltage sources. So 60 ohms, 30 ohms, 50 ohms, 20 ohms is there, 40 ohms is there, and then I do have 10 ohms resistor, isn't it? So as already I told you, see, whenever we are trying to determine the current in any of these branches, we first decide what is the current direction of all these 3 things. See, initially I am making I'll go with this one. So initially I have made my choices regarding the current directions. Now I will determine the currents now in the 60 ohms resistor. So first of all, in the 60 ohms resistor, see, this one is present only in this particular mesh, right? So what is the current which is flowing in this one? This is I1 current is flowing in this fashion. So the current which is flowing here is flowing from bottom to top. Right. Next, 30 ohms resistor. See, this is my 30 ohms resistor. It is present in this loop and it is also present in this loop, right? So if I consider this loop, the current direction is I1. So it means that I1 current is flowing. And if I consider this one, I3 current is flowing, but it is flowing in opposite direction. See, 2 currents. It is formed to two loops. One is I1 current, the other one is I3 current. So I'll take it as I1 minus I3. Why? Because I1 is in the same direction of my current assumption. I3 is in opposite direction. So I1 minus I3. And the direction which I have taken is from left to right. Similarly for 50 ohms, this is my 50 ohms. I have taken from top to bottom direction. See, it is also common to two loops, right? So coming to this loop, this is I1 current. And coming to this loop, it is minus I2 current because it is flowing in opposite direction. I1 minus I2. Isn't it? Coming to 20 ohms resistor. Where is 20 ohms resistor? This is 20 ohms resistor. How much current will be flowing? So this is I3 current, right? So only one current will be flowing. And that is I3. I3. Then it is flowing from left to right. Similarly, 40 ohms resistor. Where is 40 ohms resistor? This is 40 ohms resistor. It is also common to both loops. So from here it is I2 current and this is I3 current in opposite direction. So I'll take it as I2 minus I3 and the direction I have chosen is left to right. And finally, for 10 ohms resistor. This is 10 ohms resistor, only one current is flowing and it is I2 current from top to bottom. So like this, I have identified the branch currents along with their directions. This is my step number 3. Now moving on to step number 4. I am supposed to apply KVL for each of these meshes. So I'll go with the first mesh. This is I1, this is I2, this is I3, right? I have mentioned the currents also. This is I3, this is I1 flowing, this is I1 minus I3, this is I2 minus I3, this was I1 minus I2, and this is I2, right? These were the currents which are flowing in these branches. Now I'll take this first mesh. And mesh 1, how many elements are there? This is 1, 2, 3, 4, 5. 5 elements are there. What is KVL? Sigma voltage drop is equal to 0. So how many elements I do have? 1, 2, 3, 4 and 5. And the summation must be equal to 0. So how to determine voltage drop in each element? If I do have directly voltage, I'll take V. Otherwise, I'll take IR. Either of these things is okay for me. So I'll start. This is my first element. So it is 30 into I1 minus I3. Right. So for your sake, I'll draw the circuit here. Right. This is 60 ohms. This is 30 ohms. This is 50 ohms. This is 20 volts. This is 100 volts. Right. This was the current I1 minus I3. This current was I1 minus I2. And this current was I1. I'm moving in this direction. So this is my first one, 30 into I1 minus I3. This is the second one, right? It is 50 into I1 minus I2. See, this is the third one. I'm moving from plus to minus. I'm moving in clockwise direction, right? Plus to minus. So it is plus 20. Here I'm moving in minus to plus, right? So it is minus 100. Again, it is moving in the same direction. So it is plus 60 I1. Now understand how to write the equations. Now if you simplify this, you will get 140 I1. I'm expanding it. 30 I1, 50 I1 is there, 60 I1. So 140 I1. How many I2s are there? Only one I2 minus 50 I2 minus 30 I3. This is equal to 80. Plus 20 minus 100, it is minus 80. If I send it here, it is plus 80. This is my first equation. Similarly, if I write the second equation, now this is the second loop, right? See what is the current which is flowing here. This is I2 minus I3. This is I2 and this was I1 minus I2. So how many elements are there? 1, 2, 3, 4 and 5. So mesh 2. Again I do have 5 elements. 1, 2, 3, 4 and 5. I'll start from top left. It is 40 into I2 minus I3. Next, in the same direction, right? So it is plus 10 into I2. Again, here I am taking from minus to plus, right? So it is minus 50. Here it is again minus 20. Here it is in opposite direction, right? Because the loop is in this format, whereas the current is in this format. So I'll take minus 50 into I1 minus I2. So if I expand this one, so it is 50 I1 minus 100 I2 is 40 I3 is equal to minus 70. This is equation number 2. Right. Similarly, equation number 3. This is for mesh 3. How many elements are there? 1, 2, 3. This is I3 current. This is I2 minus I3 current. And this is I1 minus I3 current. So if I write it, mesh 3. So 1, 2, 3 elements are there. So I'll start with the top left. 20 I3. This is in opposite direction, right? So it is minus 40 into I2 minus I3. And this is minus 30 into I1 minus I3. So it is, if I expand it, so this is my 30 I1 plus 40 I2 minus 90 I3 is equal to 0. This is my equation number 3. So now I have got equations 1, 2 and 3. So now your job is step number 5. Step number 5 is solving these 3 equations 1, 2 and 3. Okay. So this is my, I have mentioned here. Step number 5. So what are the 3 equations which I have obtained previously? So this was equation number 1 and this was equation number 2 and this was equation number 3. So all 3 equations now you have mentioned it in the form of matrix, and this matrix, if it is sent to this side, you will get an inverse for this one. So my final value of I1 and I2 and I3 are, these are the currents. Once you do have the currents now, these are the mesh currents, right? I1, I2 and I3. Once you do have these currents, now we will move on to step number 6, determining the currents in each of these branches. In step number 3, we have written the table for these 3 columns. So now fill in that remaining blanks now. See, in this one I have mentioned that the current was I1. So now I do have the value of I1. So I'll substitute it. So if I want voltage drop across this one, 1.65 into the resistor. Current into resistance gives me my voltage. So this is the voltage across my 60 ohms resistor. Right. So across 60 ohms resistor, it was from bottom to top. So it will be plus 99 volts. And the current will be in this direction, 1.65. Similarly, see, for 20 ohms resistor, it was I3. So I3 I had directly value 1.5. And 1.5 to 20, it is 30 volts. It is from left to right. So, and the current flowing is 1.5 amperes. So like this, I can determine the current or the voltage drop across any of these elements. So in your question, it was mentioned that determine the current flowing in the 2 ohms resistor. Sorry, it is not 2 ohms resistor here. It is 20 ohms resistor. Okay. So in the 20 ohms resistor, what is the current? So the current is 1.5 amperes. Okay. So like this, we will apply mesh analysis for determining the currents in and also branch voltage in any of these things. Okay. I hope now you have got acquainted with the mesh analysis. I hope that now you are able to determine the mesh currents, branch currents and voltages in a given circuit using mesh analysis. Okay. So this is the problem for you. Determine the currents supplied by each battery. So you are supposed to apply mesh analysis for this one. See how many meshes are there. There are 3 meshes. Try to write equations for them. You follow the 6 steps which I have taught you in the class and get the answer by tomorrow. Okay, thank you.